students, so far what you have done in the decision analysis problems, that we did not consider any sample information before recommending D3 is the best decision. How we have recommended constructing large size complex is the best decision? Because the probability of strong demand and probability of weak demand is given. Now, we are going to conduct some sample study or market research study. With the help of that sample data, we are going to revise that probability of strong demand and weak demand, then we are going to recommend the final decision. So, the agenda for this lecture is decision analysis with the sample information. So far we did not consider the sample information, only in this lecture onwards we are going to see the effect of sample information on our recommended decision. So, here we are going to I am going to introduce a term called prior probability. Otherwise, in applying expected value approach, we showed how probability information about the states of nature affect the expected value calculation and thus decision recommendation. So, here in our problem there was a strong demand and weak demand. It was 0.8 for probability of strong demand, 0.2 was probability of weak demand. We have seen how these probabilities affect our decision recommendation. Frequently, decision makers have preliminary or prior probability assessment for the states of nature that are the best probability values available at that time. So, this 0.8 and 0.2 is the prior probability. At present only this informations they are having and they have taken the decision based on this prior information. However, to make the best possible decision, the decision maker may want to seek additional information about the states of nature. This new information can be assessed to revise or update the prior probabilities, so that the final decision is based on more accurate probabilities for the states of nature. So, initially we have the probability of strong demand is 0.8, weak demand is 0.2. So, we are going to take some sample and we are going to gain some informations. Based on that, we are going to revise this probability 0.8 to some value and 0.2 to some values. So, this probability is called posterior probability or revised probability. Most often additional information is obtained through experiments designed to provide sample information about the states of nature. What kind of experiments we can think of? Raw material sampling, product testing and market research studies are example of experiments or studies that may enable management to revise or update the states of nature probabilities. So, in our problem we are going to conduct market research studies to update our prior probability. So, then these revised probabilities are called posterior probabilities. So, how we are going to get the sample information? With the help of market research study. Assume that the management is considering a 6-month market research study designed to learn more about potential market acceptance of the condominium project. Management anticipates that the market research study will provide one of the following two results. One is they may provide favorable report. What is the meaning of favorable report? A substantial number of individuals contacted by this market research study express interest in purchasing the condominium. Then the market research study may provide unfavorable report. What is the meaning of this unfavorable report? Very few of the individuals shown interest in purchasing the condominium. That means that is why they have provided the unfavorable report. Now, the influence diagram is going to be changed slightly. How? By introducing the possibility of conducting a market research study, the problem in discussion become more complex. The influence diagram for the expanded problem is shown in the figure. Remember, previously there was complex size was there, demand was there, profit was there. Now, we have included this research study. Then the concept then the research study result. So, by introduction of this research study and its result, how it is going to affect the profit, that we will see in the next slide. Note that two decision nodes corresponds to the research study and complex size decisions. You see that there are this one and this one, and two chance nodes, research study result and demand. Two chance nodes corresponds to the research study result and demand for the condominiums. Now, you see that the comparison of influence diagram without sample information. So, this one shows influence diagram without sample information. Now, if you do a market research study, how you can see that how the influence diagram changes. This is for the comparison. It become more complicated after introduction of this research study. Finally, the consequence node is the profit. From the arc of the influence diagram, we see that demand influences both research study result and profit. So, this demand is affecting the research study result and the profit. Although demand is currently unknown to the company, some level of demand for the condominium already exists. If the existing demand is strong, the research study is likely to find substantial number of individuals who express an interest in purchasing a condominium. So, if the demand is strong, so what will be the outcome or outcome of this research study result? They will provide the favorable report. However, if the existing demand is weak, the research study is more likely to find a substantial number of individuals who express little interest in purchasing condominium. That means, they may provide unfavorable report. In this sense, existing for demand condominiums will influence research study result, and clearly demand will have an influence upon company's profit. So, what we are understanding from the influence diagram, the demand will influence the research study result and the demand also will affect the overall profit. The arc from research study decision, the arc from the research study decision node to the complex size decision node indicate that research study decision precedes the complex size decision. So, what we are understanding here, before deciding the size of the complex, first we have to do the market research study, and no arc spans from research study decision node to the research study result. So, that means there is no arc here, So, it indicates that the decision to conduct the research study does not actually influence the research study result. The decision to conduct the research study makes the research study result available, but it does not influence the result of the research study. Finally, the complex size node and the demand node both influence the profit. Note that if the stated cost to conduct the research study were given, that means the cost of conducting the research study is given, then the decision to conduct the research study would also influence the profit. In such case, we would need an arc from research study decision to the profit to show the influence of that research study cost would have on profit. Now, this is the decision tree. Look at, please remember, previously we have solved only this much portion of the decision tree in the previous lecture, because we did not do any market research study, we did not use any sample information. Now, we are going to conduct a market research study. They may provide favorable report or unfavorable report. If they provide favorable report, we have three chances. We have three alternatives. If they provide favorable report, we have three alternatives. One is D1, D2, D3. If I go for D1, there are two chance outcomes, strong demand and weak demand. The same way, if the market research study provide unfavorable report, if I go for D1, that is the constructing small size condominium, then there is a probability of strong and weak demand. First I will explain how this decision tree works. First the company's management must decide whether the market research should be conducted or not. First they have to decide from point 1, they should go for this direction or they should go for this direction. If it is the market research study direction, then these are the consequences. If it is conducted, the management must be prepared to make the decision about the size of the condominium project, this one D1, D2, D3. If the market research report is favorable, possibly different decision about the size of the condominium project if the market research report is unfavorable. If the report is favorable, they have to decide the size. If the report is unfavorable, then also they have to decide what should be the size. In figure, the squares represent the decision nodes. This one, square, 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 and the circle represents the chance nodes. You see that wherever circle is there, that is a chance. At each decision node, the branch of the tree that is taken is based on the decision made. At each chance node, the branch of the tree that is taken is based on the probability or chance. For example, decision node 1 shows that the company must make the decision of whether to conduct the market research study or not. If the market research study is undertaken, chance node 2 here, chance node 2 indicate that both the favorable report branch and the unfavorable report branch are not under the company's control and will be determined by chance. Node 3 is a decision node indicating that the company must make the decision to construct small, medium or complex or large complex if the market research report is favorable. Node 4, this one, is a decision node showing that the company must make the decision to construct the small, medium, large complex if the market research report is unfavorable. And node 5 is a decision node indicating the company must make the decision to construct the small, medium or large complex if the market research is not undertaken. Node 6 to 14 here, 6 to 6, 7, 8, 9, 10. 14 are chance nodes indicating that the strong demand or weak demand states of nature branches will be determined by chance. Now, we are going to introduce the branch probabilities corresponding to all chance nodes. If the market research study is undertaken, probability of providing favorable report is 0.77 here. Probability of providing unfavorable report is 0.23. If the market research report is favorable, then the probability of strong demand is 0.94. Probability of weak demand is 0.06. Now, I have shown branch probabilities corresponding to all chance nodes. What are they? The probability of providing favorable report is 0.77, unfavorable report is 0.23. If it is a favorable report, probability of strong demand is 0.94, weak demand is 0.06 everywhere, 0.94, 0.96, 0.94, 0.06. If it is unfavorable report, if you go for strong demand, it is 0.35, weak demand 0.65, strong, weak, strong, weak. If you are not going for any market research study, probability of strong demand is 0.8, 0.2, strong, weak, strong, weak. Now, the value of 0.94, 0.06 directly as given to you. In the next lecture, I will explain how we have got the value 0.94 for the strong demand, 0.06 for the weak demand, that we will discuss the next lecture. But at present, assume that the 0.94, 0.06 is given to you, the same time 0.35 and 0.65 is given to you. Now, we have to suggest a decision strategy to the management. A decision strategy is a sequence of decisions and chance outcomes where the decision chosen depend on yet to be determined outcomes of chance events. So, we have to suggest what path we have to follow. That suggesting that path is nothing but our decision strategy. The approach used to determine the optimal decision strategy is based on the backward pass through the decision tree using the following steps. Actually, we have to provide the decision strategy, that means what path it has to be followed, but we are going to suggest that path by doing calculation from the backward onwards, that I will explain in the next slide. A chance nodes compute the expected value by multiplying the payoff at the end of each branch by the corresponding branch probability. So, first we have to find out the expected value for each chance nodes. For example, 6 is there, we have to find out the expected value. 7, how we will find out? 0.94 plus 7. Like this we have to do for all the chance nodes. So, at the decision nodes, write that once we know 6, 7, 8, then will be the decision nodes. In the decision nodes, select the decision that leads to the best expected value. Here the best expected value is whichever is providing highest expected value. This expected value become the expected value at the decision node. So, out of this 6, 7, 8, we have to see which is the highest expected value, that value should be written in the decision node. For example, for chance node 6, what is the expected value? 0.94 into 8, 0.06 multiplied by 7, we got 7.94. For 7th node, we got 13.46. For 8th, we got 18.26. For 9th, we got 7.35. For 10th, we got 8.15. For 11th, 1.15. 12th, 7.80. 13th, 12.20. 14th, 14.20. So, we have found the expected value for all the chance nodes which are in the extreme right. See that I have shown this in the picture, 7.94 13.46, 18.26 and so on. Now, next move to the decision node 3, 4, 5. Now, we have to move left side 3, 4, 5. For each of these nodes, we select the decision alternative branch that leads to the best expected value. So, out of these 6, 7, 8, which is best? 18.46 is the best. Out of 9, 10, 11, which is best? This is best. Out of 12, 13, 14, which is the best? This is the best. So, this value we are going to enter into the decision node 3, 4, 5. For example, at node 3, we have the choice of small complex branch with EV node 6 7.94, for EV node 7 13.46 and EV node 8 18.26. So, here we select the large complex decision alternative branch and the expected value at node 3 becomes 18.26, because out of these 3, which is the highest, 18.26 is the highest. So, this value we are going to enter here 18.26. Similarly, here we are going to enter 8.15, here it is 14.20. This I have already explained. Now, you see that we have got 18.26, 8.15 and 14.20. Now, again we have to find out the expected value for the chance node 2. So, how will you find the expected value? 0.77 multiplied by 18.26 plus 0.23 multiplied by 8.15. So, this value. So, we are getting it is a 15.93. So, here we have entered 15.93, here we are having 14.20. Finally, the decision can be made at decision node 1 by selecting the best expected value between 2 and 5. This action leads to the decision alternative to conduct market research study, because this is the highest value. So, instead of going here, we should go here, because that overall expected value is 15.93. Now, optimal decision for the company. The optimal decision for the company is to conduct the market research study. First, you go for conducting the market research study and then carry out following decision strategy. If the market research is favorable, we should go for large condominium complex. If the market research is unfavorable, we should go for medium complex size. So, this is our final decision for the company. So, if I summarize what are the steps in the decision tree, the analysis of the company's decision tree describes the method that can be used to analyze more complex sequential decision problems. So, first draw a decision tree consisting of decision and chance nodes and branches that describe the sequential nature of the problem. Then determine the probabilities for all the chance outcomes. Here the probability is already given to you, but in the next lecture I will explain how to determine the probabilities, but at present assume that the probabilities are given to you. Then by working backward through the tree, compute expected value at all chance nodes and select best decision branch at all decision nodes. The sequence of optimal decision branches determine the optimal decision strategy for the problem. Dear students, in this lecture I have discussed about decision analysis with the sample information. I have explained the concept of prior and posterior probability. Then I have explained how to construct a decision tree. Then by working backward through decision tree, I have explained how to propose the decision strategy. In the next lecture, I will explain how to calculate the branch probabilities using Bayes theorem. Thank you very much.